Welcome to Brain Vision.
Problem 11.75. You've got two marbles in a container. They make contact with each other and at the 3 points A, B, and C. And now we want to find what those forces are at A, B, and C from the container acting on the marbles. And then we want to find the force between the marbles. So we have a force here, a force here, a force here. Each marble has a weight. And then there's a normal force between the marbles, and I just happen to have drawn it. The top force from the top marble and the bottom marble, but they have to be the same in magnitude. So we just apply our conditions for equilibrium. First, for point B, we know that all of the horizontal forces have to cancel. So FB is just going to equal 2 times the weight of each marble, because there are two marbles pressing downward. This is 1.47 newtons. Now, we want the angle between the line connecting the centers of the marbles and the vertical, which we draw that over here, call this theta. The sine of theta is going to be r over 2r, because we have the opposite side here is going to be the radius, and the hypotenuse has to be 2r because it's one diameter. So the sine of theta is 1/2, which implies that theta is 30 degrees. Now we use the fact that the torques have to add up to 0. And we're going to compute them about the center of the lower marble. So FC times 2r times the cosine of theta, that's the torque that C is exerting, minus WR equals 0. So then we solve this for FC, and we find that it is 0.424 newtons. And now FA has to be equal and opposite to FC, because those are the only two horizontal forces acting on the marbles as a whole. And if you wanted to be formal about it, that would be the sum of the x forces equals 0. You'd end up with this. Now for part B, we're going to consider the forces on the bottom marble. The horizontal forces have to add up to 0. We're going to have, so we have to have F sub A equal this normal force here times sine of theta. because we're only considering this marble now, and the only two horizontal forces acting on it are the horizontal component of this normal force and F sub A. So then the normal force is going to be equal to 0.848 newtons. Now, instead, you could use the fact that the vertical forces must sum to 0. It's a little bit, more things to write down, but you could do it this way. Minus n cosine theta equals 0. And then solving that, you find the same force.